So let me dive right in. So this is an experimental paper, and let's see if this is working. Yeah, and basically we are interested in the gender pay gap, right? So it's well known for decades that men earn more than women, and the literature proposes a variety of reasons, most notably differences in education, discrimination, or occupational choice. But relatively recently, a new puzzle, a new piece to the puzzle has been proposed, and that is that it may be that women shy away from competition. Right, men are more competitive, and this trait puts them in jobs that are better paid. Right, so that's a paper published in 2007 in the Quarterly Journal of Economics, which was experimental work. And let me quickly explain what was going on here. So in the experiment, subjects, they do three tasks. The first task is a piece rate task where subjects have to do, I think in their case, it was solving mazes or something. They had to solve a puzzle or a maze, right? For everything that they solved, they got a fixed reward of $1. And they had a limited amount of time, say 90 seconds, to solve as many of these things as possible, and would just get paid $1 for every unit of output that they produced. Then the second task was a tournament. So the subjects in that experiment were matched to someone else, and then both had 90 seconds to solve as many items as they could. And then the one who got most items, that person got paid $2 for every correctly solved item, yeah, and zero otherwise. So for the risk neutral agent, this would be right, the same schemes. But then in task 3, people had to choose which one would they do again, the piece rate or the tournament. And then what the results show is that men, so 73% of the men, at least in their experiments, chose the competitive scheme again, so the tournament, whereas 35% of the women chose this scheme. Yeah, so there's a huge difference. And the authors then concluded, let me minimize this a bit. So we interpret this unexplained gender gap as evidence that men and women differ in their preferences for entering and performing in a competition. Yeah, so this was like a big bomb in the literature. Of course, this is not to say that this difference in competition explains all of the gender gap. Not at all, right? I think the literature realizes that education is much more important than whatnot. It's just a small piece to the puzzle, but at least according to these findings, a pretty important one. So they say, right, this unexplained gap, that is differences in preferences. But then one of the co-authors of this piece, by the way, I completely forgot to introduce them. Let me go back a bit. So this is joint work with Aurélie Dariel and Nikos Nikefarakis, and these are both from the New York University, Abu Dhabi. So together with them, we made this project. And in an earlier project where I was not part of, but Aurélie and Nikos were, they did a literature review on this part of experiments. And we looked back in that literature, so we collected some data, and we looked at studies that had a self-selected subject pool or a non-self-selected subject pool, and then looked at the gender gap there. So let me explain briefly what is meant here. So when you have a self-selected subject pool, this is your typical lab experiment with students at campus, right? Where you flyer for an experiment, and then people decide if they want to participate in your experiment, yes or no. But also there are like non-self-selected experiments, sort of, let's say, forced experiments. And actually all papers except one in that domain are with children in class. So children of whatever, 7 years old, and then their teacher says, okay guys, now it's time for a game that we will play in class, blah, 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 right? So here there's no self-selection, right? It's just the pupils are forced to participate in the experiment. So, but what is interesting is that there's also, you see here a gap, right? So the gender gap in competitiveness is 21% for self-selected samples, but it's 12% for non-self-selected samples. But there is a confound here, because almost all of the papers with non-self-selected samples, they use children as subjects, right? So then we're not sure, is this sort of the gap that, right, goes in half, is that because of self-selection, or is that because of being children, right? So therefore, we propose to do a new experiment where we test for self-selection into the lab and use students. Yeah. So so we want to challenge, basically, or not really challenge, we want to test this assertion that the unexplained gender gap in competitiveness, is it really a preference thing, or might it also be a self-selection thing, right? Might it be that the more competitive men or the less competitive women select into the lab, and that therefore we get these results as strong as they are in the needle and Vesselin setup? Yeah. Any questions so far? Am I making sense, or?
So far, there is no.
All right. Let me continue. Okay, so let me explain the gist of the experiment that we did. So at my university, Erasmus University Rotterdam, we have in the Econ education, in year 1 of Bachelor 1, we have a course called Academic Skills. And this course needs to be taken by all students who enroll in the Econ program. So we chose the academic year 2018-2019. So that's the year before this year. So in week 1, we went to all the tutorials of this course. So it's a pretty big group. I will show the numbers in the next item. With 96 groups, and these had a maximum of 15 students that would just, have a tutorial. And in this tutorial, we would sort of quote unquote break in and say to them, look, now you're going to play an experiment, and you can earn money with that. So we explained to these students that a quarter of the students would be randomly selected for payment. And within this 25% of the students, for each student, we would randomly draw one of the tasks that they did for payment. Yeah. Note an ethical part. Of course, we break here into a class. So when we run our experiment, this comes at the cost of students being taught, right? So what we did, this is week 1 of this course, Academic Skills. And in week 1, these students are actually taught the digital environment of the school. Yeah, so they would look at Canvas, where their information about courses is stored. They were told where to find the IT desk and whatnot, right? So that was the sort of the objective of that particular class. So, and there we found a way to also have our experiment blended in, just as a way to find your way in on Canvas, the digital learning environment, to this experiment. That's basically right. So not to entirely waste precious students' time for our game, right? So the class has a total of 1,395 students who were enrolled in the class. When we did our experiment, there were 1,216 students present, but not all of them actually wanted to participate. So there were in total 1,145 students who were actually willing to participate. There are also always some people who, don't trust it or whatever, right? Or they want to work on their homework, or they just, for whatever reason, they decide not to participate. So in that respect, we cannot force everyone to participate, but I hope that you would agree with me that we have a huge fraction of the students participate. As an aside, we have, 811 males and 334 females who participate in this experiment. Yeah, just as a reference. All right, if there are no further questions, I will explain briefly how the experiment looked like. So like the needle and Vesselund setup, our experiment also consists of 3 tasks. So the first task is a piece rate. And by the way, the order of the experiment was always the same for all students. So there's a piece rate, and that meant that in 90 seconds, students have to solve as many 2-digit numbers as possible. So as many 3 two-digit numbers as possible, right? So for example, 52 plus 59 plus 25 is, right? And then they have to solve as many as possible in 90 seconds. And if they were selected for payment, and if then this task was selected for payment, they would earn €1 for every correct answer. Once this task was over, they were shown the number of correct answers that they had. Then the next task would begin, and this is a tournament where again they had 90 seconds to solve as many of the summations as possible. But this time they were told that they were in a group with 3 others, so a group of 4 in total, and that if they would win, they would be paid €4 per correct answer. Then at the end of this task, they would be informed about their score, but they would not be informed if they were the best in their group. Yeah. Then task 3 is the choice task. So this is for us the main, right? The main variable of interest. They get to choose, do they want to do again the piece rate, or do they want to do again the tournament? And then they would actually play it 90 seconds for as many summations as they could solve. And they would either be paid €1 per correct answer or €4 per correct answer if they were the best in their group. Then we had a number of other tasks. So first is a risk task. So you might imagine that your taste for competition correlates with your taste for risk, right? If you in general take more risks in life, you could imagine that you also maybe are more competitive. So we did a so-called Eckel and Grossman task. I see that there is a question.
Yes. So they say in envy study...
Oh, you're muted, Romain.
Oh. Sorry. In envy study, they control for the gender composition of the groups. Did you control for the gender composition of the groups?
Oh, that's a good question. So we did not control for the composition of the groups. I'm not sure if they did that in Needle and Vesseloon 2007 also, perhaps in some side treatments. But at least this is not what we did. So we just... we informed you will be paired with 3 other students of this whole class. So not per se the session, right? But the whole everyone who follows the course. Yeah. So the first task, besides the 3 of interest, is a risk task. So basically, how it works is there are 6 lotteries, and each lottery is a 50-50 probability. So and they increase in riskiness. So the first lottery says there's 50% chance that you win €10 and 50% chance that you win €10, right? So that's a guaranteed 10. The second lottery is slightly more risky. It gives you with 50% chance €8 and with 50% chance €12. The third one gives you with 50% €6 and with 50% €14. So and so on and so on, right? So the last basically is an all or nothing lottery. So the higher lottery you pick, the more risk is involved. Again, I see that there is a
so question. Yes, did you know anything about did they know who they were matched with, or just they were matched with 3 other students?
Yes, so they did not know with whom they were matched, right? So we would just say in task 2, for example, the force tournament, we would say you are paired with 3 other students from this course, and that's it. So also in hindsight, they would not know with whom they were paired, and also not in the beginning. They would know nothing, not the gender, nothing. All right, thanks. After the risk task, there was a confidence task. And I must admit, I think here we made a small design flaw. So what we asked the subjects afterwards, do you think that in task 2, so the forced tournament stage, do you think that you won, yes or no? That was the question we asked. In hindsight, I think we could have done a bit better. First of all, we could have asked, what rank do you think you became? This is actually what Needle and Vesseloon did, right? So instead of a binary, we could have just asked what rank, 1, 2, 3, or 4. But more importantly, we did not incentivize this task, which for economists is like an important thing, always to incentivize tasks. So we did not do that for a couple of reasons. Most notably, it just takes a bit more time to explain to everyone how this then would exactly work. And also, in hindsight, we think that the results are very comparable to what came out if this task was incentivized. Nevertheless, I think this is a design flaw. I would have done it differently with having realized that, but we can go over that later if you guys are interested in it. Finally, we asked some background characteristics. So most notably, we would ask the gender of the person. We would also ask like a subjective income question and a subjective leisure question. So we would ask in general, I have a lot of free time at my hands besides my studies, something like that. And then they could answer from a scale of 1 to 7. All right, is this clear so far? These are just the general setup of the experiment. Yeah, question, Romain?
Yeah, did you ask about their sexual orientation?
No, we did not ask about their sexual orientation, which is an interesting point because I think there is some research about this, and it does show there seemed, I think it does correlate, but also I'm not sure in what direction. But it could have been interesting to ask for it, but for us it was not really like the core of the problem that we wanted to understand, right? Our problem is basically about selection bias and not so much about risk or confidence or sexual orientation, but yeah, we could have asked it. Yeah, I think there are more questions.
So yes, there is no general question about their competitiveness.
Exactly, that's right, yes. So we could have also asked, in general, I am willing to take risk, or in general, I am competitive from a scale of 1 to 7, for example. This is not what we had in this setup. And recall, right? So we found it sort of on from the ethical side a bit tough to break into a forced tutorial and to have students spend their valuable time to our experiment. So we were given 15 minutes to do the experiment. So we had to cut down as much as we could.
Okay, new question. Did you ask the subjects whether they participate regularly to sport competitions?
No, that's interesting, yeah. So it might, right, you would expect that the students who are more competitive in sports, that it also shows here. I never thought of that. That's interesting. So I cannot go back and ask it again, right? But that's a good question, yeah. Yeah.
Another question, did you record students' nationality?
No, we also did not record their nationality, no. No, and again, right, the reason being that we just were very pressed in time. And all of the suggestions that I hear here are perfectly valid and they would be super interesting to know about, but we simply didn't have the time. All right, so there is one thing that we actually randomized, because up front, right, in this experimental design here, there's just no randomization at all. We did randomize something, namely either at the very, very first screen of the experiment or the very last screen of the experiment. We would ask subjects, would you be interested to receive an email with more information about the lab that we run here? So through that email, you could subscribe for future lab experiments. So we would ask it randomly, so the half of all subjects got this at the very first screen, and randomly half of it would get it at the very last screen.
A short question for myself, Jan. For the last screen, was it before or after they learned their payment?
So they would before, right? So they would learn their payment just a couple of weeks after the whole experiment, actually.
Okay.
So they would know, right, after task 1 and task 2 and 3, how much they got correct, how much answers. But for example, for the risk task, they would just only select a number. But then afterwards, so I think 2 weeks after we conducted the experiment, we would just, go through all of the randomizations and pay people accordingly, right? Okay. So they would not know at the time when they did this what they would be paid. So the students could write in this request on the screen that I have here in front of me, yes, please send me an email with information for signing up, or they could say, no, please don't send me information, or they could say, I am already registered. But that, yeah, no one had that because it was literally like the first class in the first week of the first year. All right, so let me show some data. And if there are questions, please go ahead, right? So here are the phases of the students all up until that they participated in the lab, right? So the first 3 bars are the percentage of the students who said, yes, please send me an email with more information, right? So here we see the students who got it before or after the experiment. We don't see much changes. That holds for all stages. So about 3/4 of the students say, either before or after the experiment, yeah, sure, send me more information. But then when we actually send out this email, we notice that about 20% of total, so not 20% of this 3/4, but 20% of the total would actually sign up through a system called ORC that we use at our university as a big database where all subjects are listed. So here's already, right, huge attrition. Then about a month later or so, we would send an email through this ORC system saying, oh, you know, next week we have a number of sessions and you can enroll if you want to. And about 8% of total would sign up for that. And then there was a small attrition, a couple of students who would actually enroll for the experiment, but in the day itself would not show up. But again, sort of 8% of the students who would actually show up, right? So, but I think the main takeaway is from here is that 3/4 of the students say that initially that they're interested, but in the end, only 8% show up, right? So there's huge attrition, so that leaves room for strong selection bias. Yeah. All right, let's go on. Okay, here are some descriptive statistics of the population and the lab volunteers. So we have 57 males entering the lab and 33 females entering the lab. So that's a total of 90 versus, the population numbers here, 811 and 334. So we see that the task 1 score for males is 5.84 and for females is 4.68, right? So it seems that males do a little bit better in their task 1 score. For task 2 score, you see that it holds still. We also see that males are a bit more confident. They have, in the population, a score of 0.28, whereas females have about half of that, right, 0.15. We see in terms of leisure that students say that they have about as much leisure. And in terms of self-reported income, it seems that males actually self-report slightly higher income than females. Yeah, so this is just some background statistics. Do note, the share of male to female in the population is 70% males, and in the lab, it's sort of similar, right? So we have 63% males of our total, the 90 people in the lab. Was there a question, Romain? Wasn't sure.
No question so far.
All right. Okay, so let's now dig into sort of the main figure of this talk. So we look at the gender gap. First of the lab volunteers, right? So of the total of 1,145 students, 90 selected into the lab. And what we did, so we look at what these 90 people did in that week 1 experiment. Yeah? And there we find that about 50% of the males chose competition and about 20% of the females chose competition, right? So huge gender gap, about 2.5 times the amount of males choose competition over the amount of females. So how is this in the population? And here we see that the gap is actually much smaller. Again, there is a gap, right? We do see again that males compete more often than females, but the gap is much smaller. It's about 2 times as small. So that's sort of our main result here. So let's look at that in regression form, right? So these are what I will present you now is a bunch of OLS regressions. And what we do is we just follow the same structure as Niederle and Westerlund reported in their seminal first paper. So when we look at the lab volunteers, so the 90 subjects, what they did, so they have a dummy female, which is highly, well, not highly, but it's significantly negative. And then there are two variables, one called tournament. So this is the score in the tournament. How many did you solve correctly in the tournament? And the tournament minus piece rate is the difference in your score in the tournament minus your score in the piece rate. So these two are, I would interpret as sort of ability measures. So when we look at the volunteer sample, we have a coefficient of minus 21%, which is roughly similar as to what Niederle and Vestlund reported for their data. And if we correct for confidence, again, in our setup, a non-incentivized measure, which I think in hindsight is a mistake, but it has like the intuitive outcome. The more confident you are, the more confident you are, the more likely it is that you choose the tournament in task 3. Question, Romain?
Yeah, question about, now it's not about sport, it's about esports, maybe people who play competitive video games regularly may react differently. Like yes. StarCraft, or I think it's Call of Duty, I'm not sure.
Yes, well, that may be right, but again, so the focus of our paper is not per se to explain who competes more or less, but the focus of our paper is who selects into the lab, right? Is competition a predictor for selecting in the lab later on? That's basically the main question. And if we look at it again, right? If we look at this graph, we do indeed see that being male is sort of, well, yeah. Predicts that in terms of, right, being a volunteer, let's put it like that, right? If you volunteer for the lab, then we see that the gap is much bigger than in the population. And then the underlying reason there, we don't know, right? Just we don't have the data is not rich enough to really say something about that. Let me minimize this a bit. All right, so this is the Niederle and Vestlund replication, but then with our own experiment and our own data. So what if we apply that same stuff to our population, and already we see that immediately, like the coefficient of female, the most interesting of the variables, just drops in half. Suggesting again that selection bias, right? So the conclusion of Niederle and Vestlund is that there's an unexplained gender gap, and a preference for competition is a big part of that, right? So these regressions actually suggest that sure, it's still there, right? There's this dummy female that is still highly significant, but its magnitude is half of that, right? So part of the results of Niederle and Vestlund are simply explained by the subjects volunteering to go to the lab. All right, let me show you some other data that we have.
Yeah, maybe just one quick question. Did you look at confidence as a dependent variable to check whether more confident people are more likely to go to the lab?
No, I will have at the very last regression will be one where we have as the y variable going into the lab, yes or no. But I don't think we really looked at confidence as the y variable.
Okay.
Yeah. So let's dig briefly into our measure of risk, right? We had here the Eckel and Grossman task. So again, so these are 6 lotteries, and you have to pick one. And each lottery gets more and more risky, with the very first one totally riskless, right? It's a sure amount, and then every lottery gets more risky. So here we see that a quite typical pattern, that males are more risk-seeking than females. It's not like that every study always shows this, but in general, we find that males tend to be more risk-seeking than females. We find that both in our lab sample, but also in our population. And again, there's like a small gap, but it's not like super huge. But the interesting thing is, once we add this variable to the regression of Niederle and Vestlund, if we add risk tolerance, then all of a sudden, so we find that more risky people have a greater probability to select into the competition, to choose the competition. But the variable female now becomes insignificant. So both for the volunteers as for the population. So also this unexplained gender gap in competitiveness, where Niederle and Vestlund were talking about, well, part of it can be explained by the gender in risk tolerance, But then, of course, the question becomes, why is there, right? Why is there then a difference in risk tolerance, right? So it sort of shifts slightly the question to the next level. But we thought it was quite interesting anyway, right? To notice that just adding risk all of a sudden makes the variable female disappear. Also, if we look at the whole population, the same regression, but we look at the interaction term. So this is the diff in diff is minus 17. So as compared to the lab sample, as compared to the population sample, the gap in the lab in gender is still 17%, right? So although females itself as an insignificant variable, we still find, if we control for risk, we still find a gender gap based on self-selection. All right, so there is also some other stuff that Niederle and Vesselund looked at, and we thought let's also look at what they, right, how that works for our population. So for one thing that Niederle and Vesselund looked at is if low performers, how do they compete? And you could think of it the following way, right? So if you have a very low score in your task 2 in your forced tournament, then you should not compete in task 3, right? But it might still be that you still compete. So for our tournament, it turned out that if you had a score of 6 or lower, you had a probability that is smaller than 25% to win the tournament. And then we would say it's not rational to enter the tournament in stage 3. Yeah, so let me repeat again. If you had a score of 6 or smaller in task 2, you would have, in hindsight, and the students would not know this, but in hindsight, you would have a probability smaller than 25% to win the tournament. And with 4 players, therefore, it would not be rational to enter the tournament in task 3. So we looked at the guys and females who had a score of 6 or smaller, who entered the competition anyway. So, and then we find huge over-competitiveness for men, right? So 42% of the men who had a too small score to compete, nevertheless competed. Women are in that respect way more rational, right? Only 5% of these. So this is for the self-selected lab volunteers. If we look at the population though, we find that the gap just is still there, but it's much smaller. Alternatively, you can also look at the guys who had a very high score, but nevertheless decided not to compete. Yeah, so they would have in our tournament, they would have a score of 7 or greater, but then still shied away from competing, although this was not the rational thing to do. So Niederle and Vesselund find results that are pretty much in line with what we find, and that is that this holds mostly for women. So women who have a high score tend to nevertheless still shy away from competing. For men also we find that, but it's smaller. But most importantly for our exercise, we don't really find a difference between the lab and the whole population here. All right, I think this is already the last. Yeah, this is already the last slide of the show, Romain. So I'm way too early.
So there is one question, meanwhile, from Ella. Can we say that the higher gap is due to the fact that men like to compete more in the lab, and not to the fact that women dislike to compete?
Yes, I'm not sure. To me, that would be sort of the way of framing.
Yeah, the two sides of the same coin. For me, the same.
Yes. Is there? Maybe I'm missing something. Perhaps the person could come online and we can chat about it.
Hela, let me unmute you.
Okay.
Yeah.
You showed the graph where you have the chart. In the lab, men compete more, but not the first one. But women do not compete less. Yes, this one.
This one?
Yes.
Yeah, exactly. Yeah.
That was the question.
Yeah, could you repeat? So your interpretation is that it's actually the men who compete more.
Yeah, this is you said the opposite at the end. You said that women shy from competition, but this graph showed that the gap is due to the fact that men like competition in the lab, and not the fact that women dislike competition.
Yeah. I agree, right? So for this slide, indeed, so the overall result shows that indeed it's the men who are more competitive. What I think the remark that I made earlier was about this one, where we look at conditional on how well you perform in task 2. We find right that men compete too much here. So these are the low performance and performers, and they compete too much. For the high performance performers, we do see, right, that if you have a high score and are female, then you have a high probability not to compete. Yeah, but in general, I agree with what you say too. But I think it's all consistent with each other.
Thank you, Hela. Now Paolo has a big question for you, Jan.
Yeah, no, it's not. I will cut it short. So the thing is about I think you have two selection stories. One is that people select into the lab, and the other people select into the tournament. And when people select into the tournament by choosing tournament, they have to think about their own performance, which you do, which you try to see in the last blogs that you showed us. But they also have to think about the performance of people that are likely to select into the tournament with them, right? So it might be that men are overconfident, so they think they are better than the others, but they might also be myopic. They don't understand that good people will self-select into the tournament. So can you, I know you cannot, but do you think would be a nice idea to look at these things? So to look if the general difference is in overconfidence or it is in depth of thinking?
Yes, yeah, that's a good question. Our data is just not rich enough to shed any light on that. But it may be. So this is getting quite a big literature altogether now, right? So I can imagine that there are papers that look at this more in particular. But yeah, so I'm sorry, I cannot.
Yeah, I know you cannot. I was just thinking about the selection, because you underlined the selection story. So different people going to the lab. It would be really interesting for in general, not just in competitiveness, to know which sort of people get into our experiments.
Yeah.
And so it is important to see if we get overconfident people, if we get not really depth thinking people. It would be interesting in general to know which sort of selection we are operating.
Yeah, it would be interesting, right, to have added like some task about how many steps ahead you can think, and then see if that would correlate with any of these outcomes. Yes.
So,
thank
you, Jan. We also have a question from Alexia.
Yes, I mean, it's generally related to difference in behavior between men and women when they are observed. I mean, there is some literature, for example, with video games, that women behave a lot less aggressive when they are being observed. And that's why I was asking my question, whether you can actually relate basically who selects into the lab, basically by how competitive they were in the classroom, vs how competitive they were in the class, so that basically you can show better that it is a selection effect, which is what you are arguing. Or what I would say is that it might be a context effect, which is that if you are in the class, maybe you feel less observed, or something is different from what is in the lab. And well, my intuition would be that it is something related to feeling observed.
All right, that's actually very interesting. So let me give a little bit more background about this paper. So it's reject and resubmit at a journal, and the editor wants us to do more, basically. And we're not really sure what the editor means exactly, so we're still thinking about it. But what I would propose to my co-authors, and we're still debating about this, but in terms of, it's now COVID, so just simply going back to the classroom and to the lab is just physically, at least in Holland here, it's just not possible. But it is possible, obviously, to go online, where I think many experimentalists are sort of forced to go to now. And I think it would therefore also be an interesting contribution in that respect. But the reason why I say this is because it touches on what you mentioned about observability, right? I can imagine that if you would do this online, then you're typically at home by yourself, not watched by anyone. Although you do know that eventually your results will be recorded, right? But you also know that you're anonymous. So that might be that But that would, yeah, but that's then a confound actually for me. If I want to compare the online results to the classroom results, I need to think about that a bit deeper. But it's a good thought. Thank you very much. Yeah.
I mean, you can if I don't think I saw this in your analysis, but maybe you did. This is just to show the who selects into the classroom, into the lab, those who were women who were more competitive, women who were less competitive, or men who were more competitive, or both.
Yeah. So I have. Let me quickly go over the last slide that we have, because perhaps some more questions will roll in. And so this is a regression where we try to explain who selects into the lab. And we just look at all the variables basically that we collected and just put them in raw. So then we find that compete. So if you in task 3 you chose to compete, right? For the males we find it have a huge effect. For the females, nothing. Counterintuitively, if you ask me, we find that risk tolerance has an opposite effect for females only. So the more risk averse a woman is, the more likely she is to end up in the lab. I'm just not sure what kind of story to attach to that. And basically, we find that all the other variables have no impact. So the amount of leisure that you have, your self-reported income, the randomization, right? If you are asked before or after the experiment, if you would like to get more information on the lab. Also something that Romain hinted about at the beginning, the amount that you get paid. Actually, we do find something here for females. The more you got paid in the experiment, the more likely it is that you end up in the lab for female. So this is sort of an intuitive result, but then again, we don't find it for males, so that makes it unintuitive. Yeah, but so this was the last regression that I wanted to show. But Alexia, does it answer any of your questions or?
Yes, very good. Yeah, thanks.
All right, cool. Thank you very much. Romain, there were more questions?
Yes, there are more. Yes, there are more. Let's unmute Bilra.
Yeah. Hello. I was just talking about a paper that is forthcoming in AER by Snowberg and Yerev. I'm not sure, maybe you have seen it. They elicit behaviors, and one of those behaviors is competitiveness.
Yeah.
Using almost an entire undergraduate student population at Caltech. And they do replicate Nidalee and Westerlund's findings with that student population. They compare lab participants' behavior to the student population, and that's like the focus of their paper. And they don't really find a lot of differences between the lab participants and the entire student population. So I just wanted to bring out that.
Yeah.
And another thing, since I have the floor now, is the gender composition of the groups matter. Nidalee and Westerlund's Orange Yellow paper, they did control for that. And when that is not controlled, gender gap gets smaller. So that may explain why in some of the online experiments, including one of mine, the gender gap is smaller. And that may be why in your study also, I think you had about 800 males, about 300 females. So looking around and seeing that as a female, you're more likely to be matched with a group of males could also make you less likely to enter into competition. So more than a question, that was a comment.
Yeah, thank you very much. The AER paper that's forthcoming, I heard about that paper last week, so I'm still, it's on my pile of papers that I have to read, but thanks anyway for hinting on that. And as for the composition question, I agree, right? There's evidence that shows that this matters. So we are interested in the self-selection part of it, and it might be still that also then matters. Although, to me that would seem like bridge further, right? It's I'm not sure if it would actually affect the way how people would select into the lab then. But nevertheless, yeah. Thanks for your comment.
So next question, or you want to finish first, Jan?
No, go ahead.
So Jack, you can.
Yeah, so my thought was if women are less competitive when they know that their gender is observed, and if you're going to be doing an online experiment as a follow-up, you could maybe have two treatments, one where you ask their gender and one where you do not, and see if you randomly assign them into the two treatment groups, the proportion should be the same. And so then you could see if the group where you don't ask their gender results in people on average being slightly more competitive.
Yes, thanks. So let me, we need to ask for gender anyway, right? Otherwise we just don't have a database. But we might ask for it at the very start of the experiment or at the very end, right? Whereas we would ask it at the very first screen, perhaps they would feel more observed about this. Is this a bit what you mean, or?
Yeah, so you ask at the beginning and then you ask at the end.
Yeah. Yeah, all right. Yeah, small note I need to make about the AR paper still, sorry. Yeah, all right. Were there more questions?
Yeah, Clarissa, you have the floor.
Yeah, hi. So I had a question about, because you were saying that you would like to get more information about why people select into the lab, right? And so obviously you can't go back now to the pool that you used, but I was thinking you could just have a really quick survey of the people in your lab participant pool and just ask them why they signed up for the experiment in the first place, right? And so the idea would be that maybe women sign up for whatever, to help advance science, or just because they think it might be fun, or they might meet people, or and men might say they're more interested in money or whatever, or at least if that were the case, then that would be a good explanation for why men, like the more competitive men who feel like, they have a better chance at winning money, might want to sign up. And then you can also ask them just about, say, beliefs about who are these other people that you think will be in the participant pool. So getting back to one of the points made earlier, then you could sort of think about, okay, so who do these people think they will be competing against, and is that systematically different? And that could be really easily done by just, doing a quick survey of the people who are in the participant pool online. It takes like 10 minutes.
Yeah, that's actually a great suggestion. Thanks. That would be neat indeed to have at least some way to look into the black box, right? If it would be indeed if most of the males would say, oh, I came here to make money, and most of the females would say something like, oh, I want to help science, or my friend signed up and therefore I thought, right, I would have nothing to do this afternoon. Yes, thanks. Yeah.
So thank you very much. We have also Vincent about the question about the science of gender. Vincent.
Yeah, I was just going off of what Jack said earlier about the gender treatments. With online experiments for Prolific or MTurk, for example, as far as I know, the information, so they have a sort of profile set up, so it says their gender and demographic information when they first set up the account. And so you wouldn't necessarily need to ask in the experiment what their gender was, as you could just pull that data from their profile. So that could be a potential treatment.
Well, but bear in mind, right? So what we look at is student population in week one of their whole studies, right? The very first week. So in hindsight, I think what we could have done is to ask for their student number, but they would then perhaps still feel observed, right? But from their student number, then we could go to the administration and retrieve their all kinds of information, I guess. But it's not like these students have that all of them have like an experimental profile or something like that, right? Only the ones who actually sign up for the ORC list. But thanks. Yeah.
Thank you.
Yep. Thanks.
So David has a short question about the gender ratio at your school, Jan, and he's surprised it's so skewed towards male.
Yes, so that's also one of the things that one of the referees came with. So the question now also is, right, well, but the population that you have is also highly selected because they choose to study economics, right? And you see from the data that it's not gender balanced, right? It's 70% males. I agree, right? But yes, I don't know how else to study this. perhaps, right? So the editor says perhaps you can go to multiple universities, multiple studies, multiple labs, and test for this.
I missed that. All of the students are econ students?
Yeah, sorry. So yeah, perhaps I could have been a bit more explicit there. So this is the first week of the economics studies at Erasmus University. So all of these, the whole subject pool are econ students. Yeah.
So I was thinking sorry.
Maybe you could give some like statistics on their undergraduate math scores. To show how selected they are. That'd be helpful. I didn't realize that they were all econ students. That would be important. Yeah.
What would be? Could you sketch some outcome that would be helpful? So
yeah. So for example, I noticed in Ganese and Rustakini's original paper at Technion in Israel that there seemed to be no gender difference in risk tolerance, and then it made sense because it was a very competitive engineering school. And the sample at Caltech also is highly selected. And so I think it's important to say something about that at the beginning.
Yeah, and would it, so let's say that we find that males and females have like an equal math score, right? What would that say about?
Well, yeah, so if I understood your results, you showed that there was no gender difference once you control for risk tolerance.
Yes.
Right, and that might help explain that.
Yeah.
Thank you.
Thanks. All right, more questions?
So I have one of my own, Jan. It's not the brightest one, but I thought in the Netherlands you had a panel of everyday men and women who take part in experiments. So I was thinking, did they play similar games, and are you able to somehow compute the extent of the selection effect of the population you have with this panel compared to what you have in your lab or at the school more generally?
Yeah, so we did not look at like a representative sample of the Netherlands. Actually, this is what they do, I think, in the AER paper, where they look at students, they look at MTurk, and they look at a representative sample of the US population. So we did not do that in this paper. Right, I'm not sure if there is data on the Dutch general population, but on competitiveness. But then the probability that they have exactly the same task as we did is like close to zero. So I would not really know how to compare that then.
Maybe you still have they played some risk aversion game, no? At least you could compare them on this.
Yes, yeah, perhaps this Echelon-Grossman task has been done by other researchers in Holland. That actually I think are substantial odds that happened. Yeah, that would also actually be interesting. Yeah, to look at how self-selected is our sample, right? If we yeah. Thanks.
But of course, those people will be self-selected from the representative population.
Yes, there's always, right. Also the representatives. Yeah, that's also self-selected. I agree. Yeah. But at least it's some data, right? Yeah. All right. Thanks. Yeah. Thanks.
So is there any other question?
I have a very quick question. Can you say a few words about the way you organized the lab sessions? Was the schedule flexible enough?
Good question. So what we did is on purpose. So we blocked 1 week where we had the lab, and every day we had a session at 10, 12, 2, and 4 from Monday through Friday. And it was in a week. It was in a week in between the last exam and the first week of the next block, let's say, like sort of in a sort of quasi-holiday week. So we hoped that this would leave enough room for subjects to pick any, right, on any given day. There were like 4 sessions, and not that the only right Monday in the morning on 9 o'clock, and then that's it, right? So we try to offer a wide variety of options. Yeah, would that be convincing or?
Yeah, thanks.
All right, thanks.
So any other question?
I have one other question.
Please, David.
So in your regression, where you showed that there was no gender difference, did you include income? I didn't see income in
No,
that.
let's go back to that 1 second. Is it this one you mean, or here's where we add
Yeah,
it?
right. So you have the data on income, but you didn't include it?
Yeah, that's right. In this one, we just try to replicate the Needle and Westerlund regression setup.
Okay.
And I'm not sure if we have the ones with income next to it. No. No. So
yeah, so that might be interesting. And
yeah.
The theory of risk tolerance says that if you have lower lifetime income, you are less risk tolerant. Of course, this is a small share of their total lifetime income. You probably won't get that. But I wonder if there's a relationship between, so you find that risk tolerance explains a lot of the behavior, and I wonder if income would add to that.
Yes, if income then would explain risk, for example.
Yeah.
I don't know, but bear in mind also our measure of income, I would argue, is rather weak, right? We basically ask from a scale of 1 to 10, are you much more, are you richer than average or much poorer than average, right? It's self-reported. So I'm just, all I'm saying is I'm skeptical that anything really useful would come out of such an endeavor, but it might explain risk. Yeah. Let me make a note. Yeah, thanks.
So
all right.
I think we're good. So thank you, everyone. Thank you a lot, Jan, for this very first presentation. It was very interesting, and I think it's very helpful for us to understand who is playing in the lab when we talk about the general validity, external validity of our papers. I think it's very helpful to have this in mind. So very good news for us. It was the first seminar we had up to 53 participants. So that's very nice. The next meeting, the next seminar is next week with Eugène. I don't know how to pronounce his name, and this is a big topic I saw on Twitter about how to pronounce his name. So he will tell us next week. So we are very happy to have you, and I thank you everyone on the behalf of Dimitri, Paolo, and Rustam, the other co-organizers. Once again, thank you very much, Jan.
You're welcome. Thanks.
Bye-bye, everyone.